Welcome to the next episode in MERN Plus AI series, where we are building a resume refiner where you can upload your resume, add your JD, and with the help of AI, you can refine your resume as per the JD, right? So we have our server till now can now remember, it can remember versions of the resumes. What we now want to add is the safety, is the security. Think of how you can upload your images on Instagram, right? Only you as a user has the right to make changes, add music, add captions. Others can only see it. So Instagram knows who you are and what you're allowed to do. That is authentication and authorization in action. Just like in temples, many devotees can go to the temple, but only the priests go to the sanctum. That is how we learn today to keep our sacred spaces guarded. Let's begin. So, to begin with, what we are summarizing is authentication means who you are. The example is logging into a system with using email and password. Authorization means what you can do. Only, for example, in our system, only your resume that you're uploading will be visible to you. So, this is the distinction, this is the feature that now we'll be adding in our project today. But before diving in, just start with this question. When a user says or demands from the system to show me my resumes, how does our backend know it's really them? Right? So today's with that thought in mind, we teach our backend to recognize its users, to open doors for the right one and close, gently close for the others. Right? Now the memory is only meaningful when we know who it belongs to. In the forest of our database, every resume must have a caretaker, which is the user. So before we talk about locks and keys and protecting and safeguarding, let us define the entity in our database, in our system. So let's come back to the code that we have been writing so far. I'll make the code available as a GitHub repo so that you can access and check. We had introduced a user entity in our system where it had a name and an email. What we want to do is add a password to the schema. So when always start with this, whenever a new entity needs to be added in the system, start with making changes to the schema. Then accordingly, we'll move and add methods for our database and integrate it in the APIs. So password will keep it maybe a string for now, right? Now we have added name, email, and password. But here comes a problem. If we store the password as a plain text, anyone, by any means, if they get access to our database, they will be able to read out the password, the sensitive data, which is probably the most sensitive data in our application, just like a plain text, and which is what we don't want. It is just like writing your ATM pin on your ATM card. It is advised not to do it, right? Because if somehow someone gets access to the card, they can go ahead and do the transaction. So each user document, when you're defining the schema, we are defining the user document. And each user document has name, email, and password. We'll refine this again in this video today. This is just the outline. This is not production ready yet. To begin with, what we'll do is we'll add uniqueness to the email, because what we want is emails should be unique per user in our application. So we'll add a type attribute to this email, make it as a string, and let's make it unique. This is the power and beauty of working with MongoDB, right? You can create schemas with, and you can add constraint just via attributes. Let's also make a required equals to true. So now our email field per user should be unique. It is a mandatory field. You cannot just create a user. You cannot sign up without the email. That is what it says, right? So let's start with this. Next, we must protect the password. And to do that, we discuss the art of hashing. How to turn a simple word into something even the database cannot read. So right now, when user, let's say they sign up and they enter the email and password as 1234, our secrets are lying bare, right? If we can somehow get access to the database, we can see the username and the corresponding email. So protection is just not about access, it is also about privacy. We don't even want our admins of the website to be able to see the password, right? So even when we are storing it in the system, and even if someone as an admin can go and see the user data, they should not be able to see the password in plain text. What we do is we'll store a scrambled version of this password, which is the hashed version, and which we'll discuss in this class. Now, hashes are a one-way transformation. You take a plain text and you convert it into a scrambled hashed version, which is very difficult to retrace back the original version, right? It is just like you're trying to prepare a dish using different ingredients and you're cooking it. After you're done cooking, it's almost impossible. I mean, it is impossible to get back the ingredients. Now, in this system, as although we are trying to add more complexity and more layers of security, but the ways to break the system is also advancing, right? It is nearly impossible is a good statement to say for password decoding once they are converted into a hash. Okay. Now, hashing is a mathematical transformation. The same input will give you the same output. But the idea is you cannot go back from that output to the input. But the problem is now the hackers, what they have tried to do is in the whenever for the malintent users, they maintain something called as a rainbow table. Okay. Now these rainbow tables have the mapping of the commonly used password and their hashes, right? So the idea is our converting password into hash is a good step forward, but every input will give the same hash. And what people started doing who wanted to break into system world, they were maintaining something called the rainbow table, which had a mapping of commonly used password and their hashes. So simple hashing is not enough. That is why modern systems don't just use hashes, they use a salting along with the hash. Now think about the salt, like when you were cooking a meal, right? Even if all of us, let's say, are following the same recipe, but the amount of salt, the taste might differ because the amount of salt that may be added per cook might differ, right? Salt as per your taste. That is what it says, right? So the salt creates a difference. This is something similar that we'll follow when we're trying to create hashes from the password. Now that we understand the idea, we want to use this package called as bcrypt.js. This is the library. This is a time-tested, battle-tested library, which helps us to hash password, right? You can read about the concept and how to safely all these documentations regarding the password, how the journey evolved, right? And what kind of how prevalent it has become, password to get leaked, password to get decoded, password to get decrypted, right? So bcrypt is one of those stable versions or options which help us to basically hash our password very securely, right? This is the command that we'll be using to include this in our project, right? We'll require the bcrypt, will create salt rounds, right? What are these salt rounds? Again, when I mentioned about salt, this is what it corresponds to. Sort rounds basically tell us how many churns of hashing your input goes through to create the final hashed output. Now you can keep increasing the rounds to make it even more difficult for any user to get back the original version, but increasing the round also comes with a cost, right? Your password hashing becomes slower. So we want to keep it somewhere around 10 or 12, which is a good place, which is a good space to be in. Right? So you generate salt and then you generate the password. Let us try to include this in our project. Now we know what bcrypt is and what bcrypt can do. Let us include that in our project. So we come to the terminal and install the package npm install bcrypt.js. This installs the node package for us so that now we can include it in our project. Import bcrypt from okay. Now that we have the project included, let us see the example of how to use this. To test it out, what we'll do is we'll just simply write our code here for demo purpose. Let's say I'm saying const plain password is equals to 1 hello 1 2 3 4, and then const hashed password. With bcrypt.js, it is as simple as just saying bcrypt dot hash and then pass the plain password. We also give the sort rounds, how many iterations, basically how many churning, how many rounds of churning you want for this plain text to be go through so that it can be converted to a very complicated hash. So let's say for now we're giving a sort round of 10. You can look at the definition also. It takes a password, then a sort. Okay. What we also see is it returns a promise, right? So in order to consume this promise, once it has been settled, we'll use the await keyword so that we have the actual hashed value back. Then we do console log. We say original so that we get the plain password. And then we say hashed. I'll just get the hashed password. Just let us run this so that we can see the output. And there was a typo. Let's fix it very quickly. You see, this original is the string, and then there is a hashed password. The pretty long, complicated alphanumeric string, right? Although it might look very difficult, but there is some hints that we can pick from this hashed value also. This is the type of encryption, and this is the sort round 10, right? And then you have your password getting converted. These are the queues basically bcrypt keeps in along with the converted hash so that when it is comparing next, when the user logs in again and they enter the password, right? It has to hash that password again and compare it. So it keeps some clue in this hashed value itself. Now let us see how the basically comparison is done. So when the user logs in, their password is hashed and stored in the DB. Nobody can figure out that this particular string corresponds to 1234. Next time when the user wants to log in, they will enter again their password. Let's see how bcrypt now compares the password. We'll just write a logic something as simple as this. Const is match. Again, we'll use await bcrypt dot bcrypt gives the method of compare where you have to give whatever user has input given the input. Let's say it is hello 1234 or what was it was 1234 only, and then the hashed password. Console.log. Let's see what it gives. Right, so now we see original hello is this, hashed is this, and it is indeed matching. Now what happens is, again, just to reiterate, it is not unhashing this password. It is hashing this password again and comparing it. It picks up the clue from the hashed string, right? Then it kind of converts and then it tries to figure out and then compare the two hashes. This is how the matching is done. Now that we have seen this in action, let us create an endpoint very quickly and test our sign up API. Let us create an endpoint for sign up, and we'll have a route handler which takes request and response objects. Correct, we have been doing this, so I think you should be comfortable with this pattern now. Now what we'll do is we'll simply create a new user once the endpoint is hit. So we'll create a new user from the user model, passing in whatever user has given as an input request.body. And then we save this document, user.save. All right. Right. Let us come to our MongoDB. We have a resumes collection. We don't have any users collection because no user has been pushed into the database yet. Let us open our Postman. And we'll create a request for sign up. Let's give it a name, endpoint name sign up. Our endpoint will be localhost sign up. Yes, it will be a post request. Let's come to the body, raw JSON, correct. Our right now our user schema takes name, so let's give it a name. Keep it name as, and we'll give it an email. Let us have node at gmail.com, and then let us have the password. The password can be 1234. Cool. Let's hit a send request. And all right, okay. Let's give it one more chance. We'll install the node mon package so that it basically updates the server on its own. We'll do that shortly. Right. So since we're not returning anything, it's still in a pending state waiting for the API to confirm, but we can go and check. Let us refresh our MongoDB. All right, so let's open our database and we see a user's collection now already existing. And we see the password in plain sight, 1234. Correct? So what we have to do is, my dear friend, is as soon as some update is happening with regards to password, we have to trigger the hashing of the password before it is saved to the database. Right? And MongoDB provides us just a utility, just a feature for that called as hooks, pre-hook and a post-hook. If you want to do something before the data is committed, there's a pre-hook. If you want to run a function or some utility after the data is committed, maybe some analytics or aggregation, then we have a post-hooks for that. So let us add our hashing logic as a pre-hook to the user schema. So what we do is, for the user schema that is defined, we create a pre-hook. So I say for my user schema, I want to attach a pre-hook so that before the save event, before data is saved, run this hook, run this function. This is again a async function because I will be using, I want to use await inside this as async function. This is now I'll be doing the hashing before the data is saved. So what I'll do is I'll say if this, which contains the record which is getting saved, if this is modified and it has the password field, you know what, please hash this. So let's have a salt rounds. We'll keep it as a 10 so that in case you want to change it, we'll have it separately. This dot password should actually be calling a bcrypt. So await bcrypt dot hash this password with the salt round. Now what is happening? This user schema dot pre, so the hook that we have attached, this tells the Mongoose before saving the user run this particular piece of function. What is this particular clause again doing? This checks if the password field was newly added or updated. If not, we skip hashing. And finally, what we do is we create a scrambled version of the user password, right? And we replace the plain text with the hashed version. All right, so we have the pre-hook ready. What we'll do is we'll drop this user and we'll test it again. Delete the document, yes, so that we can start fresh. Hit the API again. Okay, let's just run this again very quickly. Hit the request again. Yes, it looks okay. Let's come to our database, hit the refresh. And now you see that the password upon sign up is the scrambled hash version. Our pre-hook is working. It is basically hashing the plain text before it is committed to the database. All right, now the sign up is in place. When a new user signs up, their password, which is written in plain text, will be hashed and stored in the DP. The next logical step is now to introduce the login part in our application, where we user passes the email and their password, and then we compare and tell them if they are actually entering the right password or not. So let us start that. On the same lines, where we have the sign up route, we'll create a login route. In fact, let us first complete the sign up with all the try catch completely so that it is complete in its own sense. So we'll come to the sign up and then let us have the try catch. We try to move these two lines in the try block, right? So if they're saved, if everything happens successfully, return response.status 201 for creation, then send back the JSON. You can give a descriptive message saying sign up is successful. Right? If something should go wrong, our catch block will handle that. It will say response.status 400, which is user side error. Pass a descriptive JSON message with the block saying sign up failed. For now, we can have an error message showing up. We'll find all these small tidbits later, right? Probably error will also have error message. Okay, now let's come to the login route. We'll say app.post login. It will also have a your route handler containing request and response objects. Here also we'll keep a try and catch block. Shortly, we'll also learn how to handle the errors universally. We'll discuss about that when we talk about middlewares. Okay, so let's now complete the login route. From the user request, we'll try to get the email and the password that they have entered. Request.body. Then we try to find the user based on the email that they have written. So we'll say const user search for, let's say, try to find one user with the email. Okay, you can use the find and you can use the clauses also. You can use find one, find it by the email. So find any from in the user documents, find anyone with the matching email. If the user does not exist, so we'll have a check and we'll return response.status 401. This is a client side error 401 with the JSON message invalid credentials. Correct. And if everything is okay, then the next step that we want to do is we want to match the user entered credentials. So we'll say const is match. We'll use the bcrypt library that we have, the compare method it provides. We'll pass the user input password and we'll pass. Now this is where it gets, you have to understand. You will compare it with the user entered password with what is already stored in the database. So first is the user entered password. The password is stored in the user document, which it was able to successfully fetch. So our password will be user.password from the user document. So we are comparing the stored password in the database with the user entered value. If they happen to match, which is a successful scenario, so we return response.status. Well, if they don't match, that is a error scenario, right? So if they don't match, we return a status saying 401. and the JSON invalid credentials. Passwords do not match, whatever descriptive message you can choose to write. Otherwise, we return response.status success with the JSON message saying login successful. Right, so let us check now with our postman. So we have a sign up done. Let us for now tweak this to use it for login. So we'll pass our email and password. All right, and let's hit send. Login is indeed successful. If we pass a wrong password, invalid credentials 401 unauthorized, right? So now our authentication is in place. Next thing that we'll learn is basically the authorization part. How to basically authorize this particular user to perform operations across your application. We learn about the concept of JWT tokens, how to use that token, how to create that token, how to invalidate that token, and how to basically allow a user to perform an operations using the tokens. So stay tuned. We'll see you in the next video. Thank you.